Hey there! Today I'm going to show you how to use CoreML models in your iOS applications so you could introduce interesting features like, for example, object recognition for any kind of pictures used in your app. Well, first of all, let's take a look on next demo project. This is the pretty simple single screen app with the pick image button, and the user here is able to pick an image from their photos. So as you can see, this is a pretty standard set of pictures of iOS simulators. Let's try this one. And I do expect that application would be able to understand what is on the picture and put some text over here. Everything is ready at the moment. I just need to introduce the CoreML model itself. And for this project, I'm going to use the special one named MobileNet, which you can find on the GitHub project. So I'm copying it to the project right now, and we can take a look on its metadata. You can find the short description here, a list of authors. On the right, you can see 1000 objects which could be recognized from the visual inputs using this model. On the preview page, we could actually test how it works. So let's, for example, drag and drop this picture over here, and you can see that it thinks that this is a Labrador with 47% confidence. Actually, we don't even need a file. We could use the preview from the camera over here. Let's try this object. Yeah, so it thinks that this is some kind of fish, right? Salmon. Good. On other pages you can find another additional information. This one is particularly interesting. It shows that the input data for this model is the colored image, 224 pixel width and height is needed for this picture, and the output is a dictionary with strings used as key and doubles values. And basically the strings are going to be all these objects, 1000 strings, and the double values would be the probability of this object to be in that particular picture. And finally, we have the MobileNet. This is the mobile class, automatically generated Swift model class for this model to be used. So let's go to the view model of our screen and introduce this model to this class. We would need a few imports over here. So first of all, we would need a vision, and also we would need the video toolbox. All right, so let's go to the bottom of the class and introduce a new property, model. So, and as it was said in the metadata, we do need to use the MobileNet class. It has a few constructors. We are going to use this one at the configuration. So we are going to force unwrap it from try. And also we are going to use the default configuration over here. So let's take a look on this file actually and go to the definition of the MobileNet. Yeah, so over here you can see the auto-generated file, so which contains the mobile input information for this model, the MobileNet output information, and also some facades for the model itself. Please be aware that could be different in your version of Xcode, and also please be aware that it uses some tricky stuff. For example, this file is auto-generated and it uses the force unwrap. In some particular versions of Xcode it could use the main bundle and so on. So you could play with that, but I would definitely recommend then to write a proper interface to work with your particular model later. Anyway, let's go back to the view model. So I would like to introduce some new function to be used over here when the image from the picker is known and it appears on the screen. So it's going to look something like func recognize with vision. And here we are going to provide the image to find some kind of object at this image. Why with vision? Because this is the name of the framework, and this is the most simplest way on how you can make this all work. So let's use the recognize with vision at this step and just provide the image which we just picked from the picker to this method. All right, so to make it work, we would need to create the Vision core model from our model. So it's going to look something like this. So we are creating it from model, which has the property model, which is an instance of ML model type. All right. And after that, we do need to create a request to this model of Vision CoreML request type. All right. It has the completion handler, as you can see, which we are going to fill a little bit later. Let's specify the request a little bit. The image crop and scale option in particular. So what would happen if our image doesn't fit to the model's requirements? So let's just center and crop it. And finally, to make it work, we need to create the VN image request handler using our image. And finally, let's try to execute the perform on the handler using our request. So the result of this request would be handled in this completion handler. So let's first wikify self to use it in this closure. And over here, we are going to work with the request. The request has property results, which is, as you see, is a type of array of VN observations. So actually, we need a more complex type to use here, the VN classification observation, which we are going to unwrap from the results, something like this. Also, we could unwrap self here to check that it still exists. And if anything goes wrong, let's just return from the closure. All right, so we have our observations, and now let's create some method to show the first observation from the list at our screen. So it's going to be a method show. It's going to have the one single parameter observation, which is going to be the type of VN classification observation, and it's going to be optional. So, and over here we could finally execute it on self from the observations first. Nice. So what we are going to put over here, as you can see, the observation is optional, so let's actually check that the observation exists, and if it does, then we are going to construct some output string. If it is not, then let's well, use something like, for example, 3 question marks for the output string and put it to the interface. So over here, we need to construct the output string from the existing observation, and we are going to use the special format for that. So we are going to output three things over here. So first of all, the observation identifier, which is the identifier of the object, which you could see in this list. So it's going to be something like number and then some set of words. And also I would like to know the confidence of the model in this observation. It could be found through this VN confidence, which is basically a float number from 0 to 1. So let's convert it to percents and multiply it by 100. Good. And as for the format, let's just use something like this. So basically an object, and then a percent. We're going to use 2 digits after the decimal point over here. Finally, let's output this string to the interface using our main view. As you can see, it has one of the states as image picked. We do expect that by this time the image state is going to be in this image picked one. We're going to just replace one of its parameters. So the first parameter is the image which is picked and it is displayed on the screen. And the second one in this API is the string which should appear at the bottom of the image. So we are going to just replace the image state with image picked for this particular image with the new output string. And this is it. Let's try to check how this all works. So I'm picking up the object. Let's try this puppy. So as you can see, the model thinks with 41% confidence that this is a Labrador. Let's try some other objects. How about this one? Well, it thinks this is the lemon. Well, it looks like a lemon, yeah. Let's try something else. Valley, all right, I believe this. What about these flowers? This is the coral reef. All right, well, it works in some cases. How we could improve this? I would say let's try to go deeper to understanding how CoreML works, and let's work directly with CoreML, not through the Vision framework, but using the raw data. All right, so for this, I'm going to create another method. Let's name it recognize with CoreML. So it's going to have the same image parameter over here. Let's replace the previous call of recognize with Vision to recognize with CoreML and use the same image object. So to make this work, we are going to use the method model prediction for the data. And as you can see, it expects us to provide some CV pixel buffer, not an image. So how we could do that? Let's actually create an extension to the image to convert it to the pixel buffer, which is expected by this prediction method. So I will comment this out, and at the bottom of the file, let's create an extension to the UI image. So it's going to be a method because we do need to provide some parameters for this conversion. I'll leave this list empty for now, and the return result is going to be the CV pixel buffer optional, which means that in some cases we won't be able to convert the image. So let's create the actual result over here, and let's try to create the pixel buffer using the pixel buffer create method. So it looks like this. Yeah, so and as you can see, it has a lot of arguments to fill. First and most obvious would be the pixel buffer out, which is a pointer to our pixel buffer which we are trying to create. Then the allocator, well, we are going to use the default allocator for this one, no need for overcomplication. The width and height, actually we are going to provide them through the arguments, because at the moment it is unknown. The pixel format type as well is going to be provided through the arguments, and finally we need to provide the pixel buffer attributes as CF dictionary. Right, so what kind of attributes we do need here? Well, first let me copy all these arguments over here. So first of all, we are going to work with a choreographic image, CG image, so we need the compatibility with CG image. So it looks like this. The key is pixel buffer CG image compatibility, and the value is going to be the KCF boolean true. Another thing is that we also would need to provide compatibility with choreographics bitmap, because we are going to draw our image in the context of this pixel buffer. So let's also provide it over here. All right, so that's it. The CV pixel buffer creates the CV return. Let's save it in some kind of status, and after the creation we actually are able to check that status equal to KCV return success, and also that we have something in our pixel buffer, so that it is not nil. Otherwise we are going to return nil from this method. All right, so we created the pixel buffer, allocated the memory, and now let's actually create a context associated with this pixel buffer where we are going to draw our image. So for that, first we need to lock the address of the pixel buffer using the pixel buffer lock base address, and after that we would be able to get the pointer to our pixel buffer. Let's name it pixel data. That would be all right. Now we have everything to create the context. So what is here? The data, it's the pointer to our pixel buffer, which we are going to provide it right here. The width and height is known. The bits per component, well, let's use 8 bits. The bits per row, well, we could actually get it from the pixel buffer itself using the pixel buffer get bytes per row on this pixel buffer. The color space, there are multiple options. Let's use the device RGB. The bitmap, let's take a look on this. So we could instantiate with the row value. I would like to remove the alpha channel from this. So we are going to use the CG image alpha info. No skip first row value. Okay, and again, if it's not constructed, we are going to return nil from this method. Cool. Finally, we could start working with the contexts and draw our picture in this context. So let's first execute the push contexts. Then we are going to use the draw image method itself. So the origin is going to be 0, the size of the image, well, we know the size, the width and height, right? And after that we are going to execute the UI graphics pop context. Nice. So after this, our context is going to have the image drawn in our pixel buffer. So after that, we are able to finally unlock the base address of this buffer and return the pixel buffer as a result. So it is really complicated, as you can see. So I'm not sure that it's going to work as expected. So let's first try to call this method over here. So the guard let pixel buffer, I'm going to get it from image pixel buffer. So we need to provide some numbers over here. If we would go to the prediction to this auto-generated file, you can find out that, well, this prediction expects the buffer of this size and of this format. So let's just copy paste it to our parameters. So this kind of pixel format and this size of the picture. Okay, so I would like to test what actually is in the pixel buffer after all these manipulations. So here we are going to have some kind of debug code. Let's get it to the CG image. Yes, we are going to use the VT create image from pixel buffer over here with no options. When we have our CG image, we would be able to create the regular image from that, like this. Let's force unwrap it over here for simplicity. And we could actually do something like print image. So I'm going to set up the breakpoint over here to test how it works. So let's check it up. Picking the image, for example, this puppy. Yeah, and we have the image over here. Let's take a look on it. All right, so it's good, but as you can see, we need to flip it vertically, right? Not to rotate, but actually to flip it. So how we could do that? So before drawing, let's translate by 0 and by CG float for our height, right? So I'm putting it down and then I'm going to flip it on vertical axis. Okay, let's check the result right now. We have the image. Yeah, it works. Okay, so I'm going to comment out this debug code as we don't need it anymore. And now we are sure in the pixel buffer method itself. So as we have the pixel buffer, we could use it for the prediction method of the model itself. So let's use it right here. Prediction on model prediction pixel data. Also it is throwable, so let's just try with question mark over here. Yeah, so now we have the prediction, and prediction is the MobileNet output, which is, well, defined also in this auto-generated file. It has the property prop with this dictionary, which we were talking about before. So let's get the top prediction from that dictionary. For that, we are going to use the prob max, and we are going to compare the values of this key and value couple. And finally, we need to show this prediction in the interface. So for that, let's create another method, another show. But this time, instead of observation, we are going to show the prediction, which is going to be a couple of string and double, optional, right? So let's use it over here. Show top prediction. Cool. For this show, let's actually copy paste some code from our previous one. So here, instead of observation, we are going to check for the prediction, and we are going to check two values here. First for the key, and then for the value. And it is also going to be a double. It's going to take values from 0 to 1. So we're going to also multiply it by 100. Okay, let's finally test this. So what if we were going to pick this picture one more time? So yeah, now it thinks that this is the flower pot and not the coral reef as before. And this is it for today. I hope you enjoyed this video. If you have any questions about CoreML and how it works, put them to the comment section. You would be able to find this exact repository through the link in the description of the video. And see you next time. Cheers!